Okay. Hello everyone, welcome to the next session show, which is a continuation of Precision Public Health is called. I'm Nora Pasha, and for those of newcomers, I'm the new co-director of the Cambridge Public Health. So in the next session, we have 3 talks, and they vary from being about wearables, the use of data, and then about the history and how we came into what is precision health. So we'll start with the first talk with Dr. Kirsten Rainey from the MRC Epidemiology Unit. And please come in. And it's about the use of wearables in precision health, opportunities and challenges. Thank you.
How do I get it up on the screen? See if I had it. Thank you. Thank you very much, and thank you for the invitation today. What I want to talk about is, I've sort of taken a step into secondary care, but I think you'll see the link with the speakers this morning, because it may not seem like it, but when people come into a hospital, they are still people, and there's an opportunity for us to do some broader intervention and intervene on behaviours. So what I want to talk about a bit is how we use digital health tools, which in the tech term DHTs, to collect data from the patient remotely. So people come into hospital for periods of time, but we particularly saw during the COVID pandemic, people were coming in literally for their appointment and leaving straight away. And there was very little opportunity for questions and further information collection. And that really was an opportunity where we saw we could broaden that for using wearables as a passive remote measurement, for example, measuring their movement, and also for active measurements such as collecting patient-reported outcomes on apps. And today I'm just going to talk about the wearables side of that. And I want to start with, rather than me presenting data, is talking about the considerations for using these devices in healthcare. And we've already heard from yourself and from Coco, people discussing about using wearables in these situations. And it's really important to think about how we can collect sustainable and validated outcomes from devices for use in precision. And we've seen a real technology burst from when I first started back in the 1990s, and we were collecting heart rate very basically and accelerometry quite basically, to the devices that we see today, which many of you are wearing very easily on your wrist. And that allows us to, we've been able to move from electrical collection of heart rate to optical on the wrist, and from uniaxial 1-minute activity levels through to really high resolution data, which gives us the opportunity to move to think about combined sensor monitoring and collecting all sorts of things like skin temperature, movement, all the measurements we can take from the pulse, from photoplasmography, and sweat and so on from electrodermal activity. And that gives us huge opportunities to move forward, to collect for long periods on people a range of measurements. Physiologically, we can look at physiological stress with heart rate and heart rate variability, and all these that are listed here, from thinking about sleep quality and physical fitness and movement. And we can even program them to do physical function time tests, which could be done remotely in people's own homes. And that gives a big opportunity, particularly for some conditions where people are not seen for long periods of time, where they could be, this data could be collected either continuously, as you heard from Coco earlier, or in periods of time over, say, for years. But what I wanted to focus on a bit today, because I do get asked quite a lot, well, we can collect all the information from Fitbits and ActiWatches and put it all together, is it's slightly more complex than that. And we have to think a little bit about the devices that we're going to use. And that's thinking about the actual device and the software. So first of all, it's really important that it is a device that's CE marked or classed as a medical device, so that we can safely use it in patients and people. But one thing to think about is that we need to be able to understand the output and be reassured that that output remains constant over time. So I've put up here some of the things that you might see from your own monitors, where you can look at your activity, you can look at your sleep quality and stress levels and so on. The problem with those algorithms is they're constantly changing and they're proprietary to each device. So you can't compare necessarily an activity level or a sleep quality from an ActiWatch or a Garmin with a Fitbit. So when you're thinking about trying to use this to monitor people over long periods of time or make judgments on that, we need to get to the raw output. So those monitors that I mentioned earlier, those sensors, being able to get to that accelerometry data or that raw PPG signal, so that we can compare between devices, but also over time and between people. And what we can do with that is we can lock the firmware, we can lock the device so that it doesn't receive updates. So as well as receiving the raw, we don't get any change, which allows us to compare over time. And it's really important. We want to be able to collect reliable data and retrieve for several days. So we really get a feel for people's habitual activities, and not just that snapshot in time that maybe you get when someone comes into a hospital. So I've sat in consultations where they ask, so how active are you? And people go, well, it depends on the day, whether I've had treatment, whether this has happened, that's happened, and how far can you walk? And how many people here would be able to answer that question of how far you walk or how active are you? It's really difficult. It's very subjective and very specific to the day. And you may also have a little bit of a desirability bias. You might want to, oh, no, I can't walk very far, because you're wanting a particular intervention, or the opposite. So this allows us to collect data for over longer periods of time to get a better idea objectively about the individual. And it's really important that then we can use that data to process through standard process pipelines, because ultimately it's no good having these large data sets sitting there. We want to get that information back to the clinical teams as quickly as possible. And then some practical things that are really very important, which is locking the device so it can't be paired to an app and downloaded by the participant themselves, because that, A, we lose the data, but B, we may not want them to be seeing all that long collected data. We want to be able to collate it down and relate it back to them in the form of what we're discussing with them. So these are all the specifications of devices that we use. And the most important is the devices are easy to wear and acceptable to the user. So we're using wearable devices in patients from age 6 up to 93 with no problems in terms of acceptability. You don't want loads of buttons and things that somebody has to do. You want something that's very easy for people to wear that doesn't interfere in their lives. So it needs to be minimal setup and minimal input from the user, including charging. I don't know how many people like me put something on a charge and forget to put it back on. So the ideal is to have something that doesn't need charging very often, and we spend a lot of time doing user testing in the different groups to make sure that that's the case, that it's acceptable. And I think I want to draw upon some things that were said earlier about health inequalities, because that's really important. We don't want this just to be used by one tier of social group. It has to be acceptable to be used for everybody. So I'm going to skip over this, but it is important to think about that we have to be able to trace something from a device all the way through to what we use in clinical, as if we're going to use it in that sphere. And there's only been one condition that's gone through so far, which is the Apple Watch to detect atrial fibrillation. So it's really important to think about this very early on if we're going to use this in terms of precision medicine. And there are loads of opportunities for us to take the information and look at it in many different ways. So this is just an example of some accelerometry where we could look at different bouts of activity at different levels. We don't have to just concentrate on exercise. We can look at whether or not someone feels confident that they can move around for a few minutes at a time. make a cup of tea for themselves. And I just wanted to give you some examples from that slide I showed at the beginning of what we're currently doing. So in terms of diagnosis, we are looking to use the wearables to identify patients who are at risk of frailty. So they haven't developed frailty, but they are at risk. So that there is an opportunity to recall those patients back in to clinic, to undertake a clinical frailty assessment and to intervene. And so this is the example of where you could use this for precision medicine and actually reduce the impact in terms of clinical resource. Because rather than doing an assessment on everybody, you can actually pinpoint the people who need more help. Similarly with prognosis, we're looking at how we can evaluate patients' physical function activity levels for surgery. So they're in a better position for surgery before they go in. And this is in orthopedic surgery. So this is giving the opportunity for us to use some of the really great programs that are around for prehabilitation, but pinpoint the people who really need that. And we're also, on the other side of things, looking at how we can use wearables to help in terms of treatment. So we're undertaking a study at the moment where we're looking at the effect of treatment and perhaps the requirements for titration for that, and also on outcome. So I've run out of 10 minutes, but I know we've got a panel and I'll be around at lunchtime for people who have questions. I just want to acknowledge some of the wonderful clinical teams that I work with and my team at the MRC Epidemiology Unit.
Thanks very much, Kirsten. So we'll take the questions at the panel discussion. So next we move on the issues that you brought on data. Therefore, access to data is very important no matter whatever we're collecting. So we move on with Dr. Amy Orban from the MRC Cognition and Brain Science Unit. Thank you.
Thank you. I'm quite new to Cambridge Public Health, so just as an introduction, I lead a program at the MRC Cognition and Brain Sciences Unit. And I started really focusing on social media use in teen mental health, and that's still a big focus of mine. But we're increasingly thinking about digital media in general and how it interfaces with health and education and behavior across the whole policy landscape. For example, I feed into the Department for Education on their scientific advisory board of one of the 12 national experts focusing specifically on the role of the digital. So why care about digital media or social media for precision public health? Hopefully I can use these 10 minutes to convince you that this type of information is really critical for public health in the 21st century. And that's because, for example, young people spend up to about 6 hours a day online. And while we study the impact of schooling, for example, with substantial amounts of funding and a long history, the amount of understanding we have on how the digital world impacts their beliefs, their behaviors, is still relatively minimal. So digital media, and I'll focus specifically on social media as on the slides, impact public health in sort of two main ways. So in the first hand, we can use it to track phenomenology or symptomatology at a very early stage. So we always say one of the most sensitive pieces of digital information is probably your Google search history. I would never want anyone to have access to my own, and I think if we think about what we put into those platforms, those have a wealth of information. But also, for example, on TikTok, where algorithms really understand where your interests lie and update at a really quick rate, that can be used to track how a person is feeling, but also things like symptoms that they are concerned about. But also, the second mechanism is that the content that we see will inherently change how we feel about ourselves and our behaviors. So we do a lot of work on the impact of vaping, alcohol content, dietary content on social media. That's sort of in the public health space, do a lot of work on, for example, skinny bodies and how that influences body image as well. And I'll talk to you a bit about why data donation, which is a new method to get access to social media data and other forms of digital data, is so exciting. That's because while there is all that wealth of information, Google will not give you or a researcher access to that sort of free of charge or at all, really. Or TikTok wouldn't want to give public health research access to the amount of alcohol content that's being displayed or vaping content or violent content online. However, there has been a change in how we can access this over the last few years. So for about a decade, Meta or ByteDance were telling me we can't share data because of GDPR, because of our data regulation and security. However, GDPR gives us all the right to access our data and request it from companies, and this is what data donation does. So while a participant can come into my unit and donate their time, they can donate their brain scan, they can donate their blood to research, or if we go to the hospitals, their tumor samples. We now are developing mechanisms to allow them to donate their digital data, all on the basis of their right as an individual under our data legislation. So this is extremely exciting because it allows people, it boosts people's agency in allowing to share their digital data, and it gives us a completely new resource for starting to study these sorts of forms of data and what they could do. So I'll quickly run through you what data donation might look like. So we've been working very intensely with researchers in the Netherlands to build a very secure data infrastructure that would allow us to do this. So for example, we recently ran a trial in schools. We had about 300 students sign up. They would go to TikTok and Instagram. They would request their data from them. That's on the click of a button. It might take a day or two for that data to be sent to them via email. They then go to a website. They can upload it there. But that data package that they get is really sensitive. It has things like all the messages you sent to your friends, your name, your contact details. So on that website, it's still on their server. We run scripts that extract only the data we want for research. Using co-creation with young people, we then created a digital visualization tool where they can play around with their data. They can have a look at what we're interested in, the types of data we would like to collect. And they can see, for example, how often they use TikTok at different times of the day, or how many videos they watch across the year. And then there we have an additional consent step, where only once they've seen what data we want, they get to interact with it, they can donate it to us as researchers, which gives us additional security that they really understand what they're sharing. So for example, for TikTok, we get every single video link that they watched over the last 6 months. So this is a wealth of information because about the average young person watches about 500 videos on TikTok per day. And those fluctuate. So really excitingly, a core collaborator of mine just got about 7.6 million to expand digital data donation across the UK and create this sort of data infrastructure across the landscape. And I sit on the program board of SDR UK, which has funded this. So if you're interested in this sort of space, please let me know. We can get things like Tesco Club Card data or Amazon purchases. So it's really not just social media, which is of my own interest. Further, new EU legislation means that people should now in the EU should be able to donate their data continuously, so in real time. This led to a flurry of different developments, mainly for EU populations. But after substantial pressure of mine into the new governmental legislation, some of the companies have now opened that up to UK researchers or UK populations as well. So for example, for TikTok, we don't need to have people request their data and wait for a couple of days and then upload it anymore, which is high effort. They can actually log in via what we call an API and consent to that transfer automatically. And we can consent to transfer into the future as well. So this is extremely exciting for cohort studies because at one consent, we can then start tracking, for example, the videos they watch in for however long we told them the consent or they consented for that data to be shared. We're now working with Bourne and Bradford and other cohorts to start to scale this method across the public health data collection landscape. Personally, we have started to try to showcase the value of this research. I think we're just at the very beginning, and if you think, your area might be of interest, I'm more than happy to share. We're just trying to build an expertise in the method. But for example, we have just collected TikTok data on all the videos young people watch from these 300 young people in Cambridgeshire schools. They also tracked how they felt, their mood and their body image 3 times a day over 2 weeks. And so we're starting to use AI to code, those 500 videos a day and start tracking if they start watching more videos that have more skin showing or that have more stereotypically beautiful beauty standards content, does their body image drop and vice versa. We're currently putting in quite a few funding applications to extend this to harmful behaviors like alcohol, vaping, as well as other types of mental health content like mental health disinformation. For example, there's this if you have time, go on TikTok and start looking at the sort of ADHD or autism content that is being displayed. There's a huge amount of disinformation, and just the first Scientific Advisory Council meeting at the DFE 2 weeks ago, their main topic was the amount of SEND diagnoses in schools of special educational needs, and that the amount of ADHD and autism diagnoses are massively increasing to the extent that we're struggling to keep up. And while I think there's a lot of kind of different factors that will be involved, I think social media will be playing a part, and these methods will be what allows us to start studying those. So I'll go over there. So I think that I just want to end on that if we're studying public health, but any sort of personal process of a patient or a child in the 21st century, we need to start studying what they're consuming in the digital world. We often sort of study it with one questionnaire item, or we ask them at the end of a clinical assessment. But we now need to start building the tools to actually understand that, not just to help them, but to start holding companies to account for the sort of content that they're displaying, for example. And I'm more than happy to talk to you at lunch. Thank you.
Excellent. Thanks very much, Amy. So it's a great pleasure now to welcome Dr. Ron Simmer, so visionary mentor, and he's the founder of the Public Health Genomics, and I'm sure it will be thought-provoking talk and get us back to the basics of understanding what is precision health.
Which is the, how do I move the slide? So, is it this one?
Yes.
Yes, okay. Well, it's a great pleasure for me to be here. It's a particular pleasure because, as you've heard, I've been working in this field of genomics and public health for 26, 27 years. For those of you who don't know me, before that I was Director of Public Health in Cambridge and also the Director of the Institute of Public Health here. There's a lot to get through in the next 20 minutes. And so I'm going to, with my slides, some I will concentrate on, others I will just flash up so that you get an idea. So the next, is the structure of my talk. I've got to get through quite a lot of stuff here, so I won't say much about this slide. It just gives you an idea of the sorts of things I'm going to be talking to you about. Which way go? Which way is? I can't. So, public health genomics, its historical context. I don't want to say a huge amount about this. I started it in 1997 when I was Director of Public Health in Cambridge, and realizing that the Human Genome Project going along, and there was absolutely no one, or hardly anyone in the Department of Health that knew anything about genomics. And to cut a long story short, we got a group of experts interested in this from mainly Europe and the North American continent to go to Bellagio in 2005, where we actually agreed some of the basic tenets of the subject. So we're well known, we've been going in this space for, as I say, over 25 years, and we've made lots of links. So what came out of Bellagio, and there were two things I want to really say to you. One is that we defined the field of public health genomics, and note the term genome base, not genomics knowledge. It's all the biology downstream of the genome as well, what we would now call perhaps biomarkers. So that's the first thing. The second thing we developed was this thing which we called the enterprise diagram, which basically says, if you look at the stuff in red, that you're a brilliant genomic scientist. You may have the FRS, you've had 10 publications in Nature or Cell, but that in itself will not get the improvements in population health, which is what you seek. And that in order to do those, you have to work in a multidisciplinary fashion. You need to work with population and management sciences, things like biostatistics, epidemiology, and indeed now systems science in the engineering department and so on. And you also need to work with people in the humanities, people in fields like law, philosophy, anthropology. And then you need the bit in blue, which is what we have been doing for 25 years in the PHI Foundation. All those things in order to get improvements in population health. Now, this is very old. This was, early 2000s. Now, I suspect it's the engineering department through their systems approach which will define in much greater detail what that blue bit is. But the point is there needs to be an explicit process. So this is what we are today. You can read that there very quickly. I don't want to spend time on it because there are other things I want to talk about later on. But the basic tenet of public health genetics that I want to talk about is just on this slide. And the one that I'm going to talk most about is the stuff in blue. It's well known to public health people. They are the determinants of health. And I've put the determinants of health in a diagram like that because I want to emphasize three things. First of all, your genomic makeup, your genetics are part of those determinants of health. And this was something that public health people never sort of really put into their concept of determinants of health. Second, those arrows. They are all interrelated. There is no such thing as something that happens because of some political thing there or some environmental agent such as a pathogen or your genomics. Everything contributes to your physiological traits and your diseases. And the pink diagram below really is just meant to show that everything comes about because of the combined action of genetic and environmental factors. Even being struck by lightning, because your genomic architecture will determine whether you're a person that likes the outside life, likes going climbing, or rather you're a sedentary person living indoors. There is nothing that is just genetic or just environmental. Everything is linked. So, move away now. There's been a problem for many years, not just in the UK, but across the world. There's a crisis in healthcare because all countries have financial stringency and demography, science and technology push, and rising patient expectations have fueled this sense of disengagement between what is available by way of financial resources and what needs to be done. And the reality is, you'll see at the bottom half of the left, is that the classical public health approaches have not worked. The one-size-fits-all solution has not been totally successful. So as far back as 2014 and probably before, this is just one example of a EU Commission report, which I think was funded by one of the pharmaceutical companies, AbbVie, sort of said, well, to solve that, we need a radical rethink of service organization, this move from hospital to community. We need to shift from diagnosis and treatment to disease prevention. And we need to empower the citizen to take greater responsibility for health. Well, that was back in 2014. What Lord Darzi prescribed a few weeks ago, wasn't much different to that, moving from analog to digital, so on and so forth. And indeed, in a report that came out a week or two later, the IPPR report, which was chaired both by Lord Darzi and Dame Sally Davis, said sort of much the same thing. And so that's why personalized medicine. Now, we can't do anything about demography. I mean, it's out there. It's part of the world. People are aging and so on. But we can build on innovation and the innovation pathway. And we can even build on this rise of individualism, which might be a bit counterintuitive. But that is certainly the case. And in some senses, the new paradigm of personalized medicine has your challenges, the solutions which I'm talking about, and so the primacy of the individual and personalized medicine. I've got 20 minutes. And so the primacy of the individual and personalized medicine, and I prefer to call this personalized medicine rather than precision medicine, purely because there are two sides. There's the side which you might call proper precision medicine, which is about biological individuality. But the other side is the art of medicine. What our mayor was talking about, the compassion, the doctor-patient relationship, that's part of personalized medicine at all. And again, just to show that none of this is new, both Leroy Hood in the States and Eric Topol have talked about this. This is just one book, The Creative Destruction of Medicine, from old to new medicine, bringing together all this biology together with all these other technologies. And central to all this is data. I mean, data is absolutely at the core of all this. And so in the last 20 years, we've seen this, and in the next 20 years, there will be more of this, growing exponentially. And the primacy of data sharing, and that was really what the last talk was very much about, is that by bringing together the genome-based sciences and the digital sciences, it provides the infrastructure without which personalized and precision medicine cannot flourish. So in public health terms, what we're moving from, the public health practitioner in the 19th century was the sanitary engineer. In the 20th century, the social engineer. In the 21st century, the public health practitioner will be the information manager. So, social and biological determinants of health. I have told you in the first slide that they all work together, that they are not in tension with each other. But many people speak as if they were in tension with each other. This is not new. Sir Douglas Black, Professor of Medicine at Manchester, a wonderful book in 1984 on an anthology of false antitheses. He saw the distinction between individual and population, treatment and prevention, hospital and community as false antitheses. And any attempt, he said, to pit one against the other was false, pointless, and even detrimental to healthcare. In 1991, Kerr White, who was a senior executive with the Rockefeller Foundation, asserted that the two cultures of public health and clinical medicine, and in his book he traced the history of the development of the growth of public health in the United States and the growth of clinical medicine, he said they lived in separate and often unfriendly worlds. And he tried to bring the two together by promoting the field of clinical epidemiology and establishing what was called INCLIN in the 1990s. And again, that was only partially successful. So I finish by talking about two individuals. The first is Professor Geoffrey Rose. Now, everyone in public health knows of his distinction between population and high-risk approaches to prevention. In this example of blood pressure and sodium consumption, if you reduce the sodium consumption, moving the blue curve to the left to have the pink curve, the average blood pressure of that population is lower. And again, what he pointed out very clearly were that this high-risk approach, treating people with high blood pressure to the right of the dotted line, and the population approach were complementary. But what most people do not realize is his distinction between causes of cases and causes of disease. That basically, this talks about populations, but what is it that determines whether you sit under the high or the low sodium curve are on the left-hand side or the right-hand side of the curve? Well, that is your genetics and your lifestyle experiences, everything except, because this is about blood pressure and sodium, that determines that. And this is what genetic epidemiology is about. It's not trying to establish the causes of incidents, but the causes of cases. What determines if you're a child living within, say, 20 miles of a nuclear processing plant, where causes of incidents tells you that you have a higher chance of childhood leukemia, but what is it that determines that you and you get the childhood leukemia, but you and you do not get the childhood leukemia? That's causes of cases. The second person I want to finish with is Ernst Mayr, who was a philosopher of biology who died in 2025, aged 100. And he wrote an essay on typological and population thinking. So the question is, what is a population? Is it a homogeneous population, a single ontological entity? Or is it a set of individuals? And in this essay, what Mayr pointed out was typological was the old way of thinking. It goes back to Plato's theory of ideas, that what was important, if you take animals, was the idea of dogness or catness. The fact that every individual dog and every individual cat was different was just a mere accident, piece of epiphenomena. What was important was the type, dogness or catness. And that the population average was therefore more important than the individual in the population. And what Mayr pointed out is post-Darwin, hey, you can't think like that anymore. Because evolution and its mechanism, natural selection, works through individual organisms. It doesn't work on the population, it works through individual organisms. And that the primary thing that you should be concentrating on was the individual dog, the individual cat, the individual human being. That was the important thing. And that averages are merely statistical abstractions. Only the individual has reality. So to finish, back to the past. For 4,000 years, clinical medicine was a transaction between doctor and patient, a one-to-one relationship. We've now reverted, because of the influence of evidence-based medicine, to a one-size-fits-all paradigm, and to the use of guidelines which are based on epidemiological studies which are about averages. Whether they're observational studies or case control studies or randomized clinical trials of drugs. The fact that if you take a statin, you can reduce your cholesterol by 30% no matter what statin you take, doesn't tell you much about the response of the individual. For all one knows, the population may be such that half the population taking statins does no good at all. doesn't reduce your cholesterol, and for the other half it reduces it by 60%. We need to see what the frequency distribution graph by effect size is. So the evidence-based medicine movement made little attempt to make allowance for variation between individuals. Modern biology and our understanding of evolution and how it works shows that this must be wrong, and that the individual must be placed at the heart of all healthcare, and I suggest of all public health, and that the failure of public health leaders to understand that this is so, and to prioritize social and structural and political determinants over the biological determinants of health is harmful. They are equally important. I'm not saying that the one is more important than the other. They are equally important. So the population in the 21st century is best conceived of as a set of individuals rather than an entity in its own right. So these are the conclusions. We can no longer ignore the knowledge derived from genetic, cell, and molecular biology. Biological and social models of disease must be regarded as complementary paradigms by policymakers, and that health, leadership, and practice must take into account the three things I've set up there, and that the personalization of healthcare cannot and should not be considered a thing in itself and of its own right. It must be grounded in the transformation of healthcare in its identity, fitting within plans to produce a sustainable health system that is ethically, practically, and financially sustainable. Sorry, the word sustainable. Thank you very much.